Walk into any grocery store in America right now and pick up a can of soup. Somewhere on that can, printed directly onto the label, you will find a small rectangle of black and white vertical stripes sitting above a row of 12 numbers. You have seen this pattern so many times in your life that your eyes probably slide right past it. You do not think about it. Nobody thinks about it. It is the most ignored piece of technology in the world. But that small rectangle changed the way humanity buys and sells everything. It changed how stores operate, how warehouses manage inventory, how supply chains move goods across continents, and how the global economy tracks the billions of products that flow from factories to shelves to shopping carts every single day. Before it existed, the entire retail economy ran on a system of handwritten stickers, manual data entry, and monthly clipboard counts that was slow, expensive, and inaccurate in ways that cost the industry billions of dollars a year. And it did not exist before 1974. Before that rectangle appeared on a pack of chewing gum in a supermarket in Ohio, every item in every store in America was priced, tracked, and sold by hand. The system that replaced it was conceived on a beach, perfected in an engineering lab, and proven on a 10-cent pack of gum that is now on display at the Smithsonian National Museum of American History. And the road from that drawing in the sand to that beep at the checkout counter took 25 years, because the idea arrived a quarter century before the technology needed to make it work. To appreciate how much the barcode changed, consider what grocery shopping actually looked like before it arrived. The process that seems so simple and fast today, scan the item, hear the beep, see the price appear on the screen, drop the product in a bag, was not simple at all in the decades before the barcode arrived. It was the product of an enormous amount of invisible human labor that most shoppers never saw and never thought about, labor that consumed a significant portion of every dollar the store earned, and that the industry desperately wanted to eliminate. Every item in a grocery store had to be individually priced by a human being. When a shipment of canned vegetables arrived at the back of the store, a worker would unpack the boxes, load a pricing gun with a roll of adhesive stickers, and apply a small price tag to every single can. Every can of corn, every can of beans, every can of tomatoes, one sticker at a time, applied by hand, thousands of stickers per day in a single store. A typical supermarket in the 1960s carried around 8,000 different products on its shelves. Every one of those 8,000 products needed a price tag, and every price tag was applied by a worker whose labor cost the store money it could barely afford to spend. The pricing gun itself was a simple tool, a handheld device that printed a number on a small adhesive label and applied it to the product in a single squeeze. Workers could price between 400 and 600 items per hour with a pricing gun, which sounds fast until you consider the scale. A store receiving 1,000 cases of new merchandise in a single day needed to price every item in every case before it could go on the shelf. The pricing crew was one of the largest labor costs in the store, and their work was never done because new shipments arrived every day. When prices changed, the process was even more painful and more expensive. If the wholesale cost of a product went up and the store needed to raise its retail price, a worker had to find every unit of that product on every shelf and in the back room, peel off the old sticker, apply a new sticker with the updated price, and return the item to its position. In a decade of rising inflation like the 1970s, when the cost of goods changed constantly, the labor required to keep price tags current consumed an enormous percentage of a store's already razor-thin operating budget. A single industry-wide price increase from a major brand could mean thousands of sticker changes across hundreds of stores, all done by hand. At the checkout counter, the process was equally manual and equally prone to error. The cashier picked up each item, found the price sticker on it, and typed the number into the mechanical cash register by hand. Key by key, item by item, customer by customer, all day long. An experienced cashier who had memorized the location of price stickers on popular items could process a customer's groceries at a reasonable speed. But even the fastest human fingers made mistakes. Studies from the era estimated that manual price entry errors cost the grocery industry hundreds of millions of dollars a year in aggregate. Sometimes the cashier hit the wrong key and typed $4.19 instead of $4.91. Other times, the price tag had fallen off and the cashier had to guess or send someone to check the shelf. Occasionally, the sticker showed the wrong price because it had been applied before a price change and nobody had caught it. Every error either cost the store money or overcharged the customer, and neither outcome was good for business. Inventory was the third bottleneck, and in some ways the most damaging to the bottom line. Before barcodes, the only way to know what was actually on the shelves was to count it physically. A worker would walk the aisles with a clipboard and a pencil, counting every item on every shelf and in every backroom storage area, category by category, brand by brand, size by size. This process was so time-consuming and so labor-intensive that most stores only did a complete inventory count once a month or even less frequently. Some smaller stores did full inventories only once a quarter. In between those counts, store managers had almost no reliable data about what was selling and what was sitting. They relied on estimates, gut feelings, decades of personal experience, and the occasional observation that a section of shelf looked empty. The result was chronic inaccuracy that cost the industry billions of dollars a year in two ways. Stores frequently ran out of popular items because nobody had current data showing that stock was running low. A customer who came in for a specific product and found the shelf empty would buy a competitor's brand or go to another store entirely, and the sale was lost. At the same time, stores routinely overstocked slow-moving products because nobody had accurate information about what was actually selling. Products sat on shelves for weeks, taking up space that could have been used for faster-selling items, tying up capital in merchandise that was not moving, and sometimes expiring before it could be sold. The grocery industry was running on the thinnest profit margins of any major retail sector in the American economy. By the late 1960s, the average supermarket made less than 1 cent of profit for every dollar of sales after taxes. Labor costs were the single largest expense, and a significant portion of those labor costs went directly to the manual processes of pricing, repricing, checking out, and counting inventory. The high inflation of the era made the problem worse because prices changed more frequently, which meant more relabeling, more errors, and more labor hours consumed by work that added no value to the customer experience. The industry was looking for a solution, and it had been looking for one far longer than the history books suggest. Before the barcode concept even existed, grocery stores had tried various approaches to speed up the checkout process, and all of them had limitations. Some stores experimented with pre-printed price lists mounted at each register that cashiers could reference instead of reading individual stickers, but this was only marginally faster and still required manual key entry for every item. Others tried color-coded shelf labels that corresponded to price ranges, but the system was confusing for cashiers and prone to error when products were placed on the wrong shelf. One ambitious attempt in the 1950s involved encoding prices on punch cards attached to products, which a machine at the register could read, but the cards were bulky, expensive, and fell off the products constantly. The fundamental problem was that every proposed solution still required either a human to read something and type it in, or a physical tag attached to every product that could be lost, damaged, or applied incorrectly. What the industry needed was a way to permanently mark every product with machine-readable information at the point of manufacture, so that the information traveled with the product seamlessly from the factory floor to the warehouse to the distribution center to the store shelf to the checkout counter, without any human having to apply, read, interpret, or type anything at any stage of the journey. That concept, a permanent machine-readable mark on every product, existed in the mind of one man who had drawn it in the sand on a Florida beach 2 decades earlier. But the technology needed to bring it to life. The lasers and the microprocessors and the high-speed printers had not caught up with the idea. The barcode had been invented a quarter century too early. It just could not be built yet. The idea for the barcode was born in 1948, and it started with a conversation that happened to be overheard by the right person at the right time. A manager from a local supermarket chain in Philadelphia had visited the Drexel Institute of Technology and asked a dean whether the school's researchers could develop a system for automatically reading product information during checkout. The manager was frustrated with the inefficiency of manual pricing and checkout and wanted to know if science could offer a better way. The dean declined the request, saying the problem was interesting but not something the school was equipped to take on. But a graduate student named Bernard Silver happened to be standing within earshot, and he was intrigued enough to mention the conversation to his friend and former classmate, Norman Joseph Woodland. Woodland was a mechanical engineer who had served in the military during World War II, working as a technical assistant on the Manhattan Project at Oak Ridge, Tennessee. After the war, he completed his degree at Drexel and stayed on as a graduate instructor. He was 27 years old, intellectually restless, and immediately captivated by the supermarket problem. He had learned Morse code as a Boy Scout, and the idea of encoding information in a visual pattern that a machine could read felt familiar to him. Dots and dashes communicated information through sequences of short and long signals. Why could not lines of different widths do the same thing? In the winter of 1949, Woodland was sitting on a beach in Miami, where he had gone to think about the problem in a warmer climate. He reached down and drew his fingers through the sand, pulling 4 lines of varying widths and spacing across the smooth surface. As he looked at what he had created, 4 simple lines of varying thickness scraped into wet sand by his own fingers, he realized that information could be encoded in the pattern of thick and thin lines, just as Morse code encoded information in dots and dashes, but in a visual rather than auditory format. Instead of arranging the lines in a simple row, he imagined them running in concentric circles like a bullseye or a target, so that a scanner could read the code from any angle regardless of how the product was oriented on the checkout counter. The circular design meant that the scanner did not need to be aligned with the barcode in any particular way, which seemed like an important practical advantage for a system that would be used by busy cashiers handling products at high speed. It was one of those moments where a concept that would change the world looked, from the outside, like a man idly drawing shapes in the sand. Woodland later said the idea felt obvious once he saw it, like it had been waiting for someone to connect 2 existing concepts, Morse code and visual pattern recognition, in a way that nobody had thought to try before. Woodland and Silver spent the next 3 years developing and refining the concept. They built a primitive prototype using a 500-watt incandescent light bulb as the light source and an oscilloscope to read the reflected light patterns. The device was enormous, clunky, and impractical, but it proved that the fundamental concept was sound. In October of 1952, they were granted United States Patent Number 2,612,994 for their circular barcode design. The patent described a system of concentric rings of varying widths that could be illuminated by a light source and decoded by a photoelectric detector. It was elegant and innovative and completely ahead of its time. The compact lasers, affordable microprocessors, and reliable high-speed printing techniques needed to make the system commercially viable simply did not exist in 1952. The patent sat unused, a solution on paper to a problem the world was not yet equipped to solve. Woodland joined IBM in 1951, where he continued working on data encoding technologies. Silver remained in academia. Neither man profited significantly from their invention during the years when the patent was active. They eventually sold it to the Radio Corporation of America for $15,000, a fraction of what the technology would ultimately be worth, and a transaction that Woodland later reflected on with characteristic good humor rather than bitterness. The barcode had been invented. Now it needed the rest of the world to catch up. If you want more stories like this, subscribe. Now let me tell you what happened when the technology finally caught up with the idea. For 15 years after Woodland and Silver sold their patent, the barcode remained a solution waiting for the right technology to arrive. The photosensitive detectors of the early 1950s were too slow and too unreliable to read a barcode at checkout speed. The computers needed to decode the pattern and match it to a product database were the size of rooms and cost hundreds of thousands of dollars, far beyond what any grocery store could afford. And the light sources available, ordinary incandescent bulbs, were too diffuse to illuminate a small barcode pattern with the precision needed for reliable scanning. 2 breakthroughs in the 1960s changed everything. The first was the development of the laser, specifically the helium neon laser, which produced a concentrated, coherent beam of red light that could illuminate a barcode with pinpoint accuracy and scan across its surface quickly enough to read the pattern in a fraction of a second. The second was the rapid decrease in the cost of computing power driven by the invention of the integrated circuit and the microprocessor. A computer capable of decoding a barcode and looking up the corresponding product in a database was no longer a room-sized mainframe. By the early 1970s, it was a device small enough to fit under a checkout counter and affordable enough for a grocery chain to justify the investment. The grocery industry, squeezed by rising labor costs and desperate for any efficiency gain that could protect its vanishing profit margins, began actively pursuing an automated checkout solution. In the mid-1960s, the National Association of Food Chains launched an initiative to explore automated pricing and inventory systems. In 1966, Kroger grocery stores and RCA collaborated on a pilot test of barcode scanning at a Kroger store in Cincinnati, Ohio. The system used Woodland's original circular bullseye design, which RCA had acquired along with the patent. The pilot demonstrated that the concept was fundamentally sound, that a machine could read a code on a product and match it to a price in a database. But the bullseye design had a critical flaw that could not be overcome. The circular pattern tended to smudge and distort during the high-speed printing process used to apply labels to products, producing codes that the scanner could not read reliably. The smudging problem was severe enough that the bullseye design was ultimately abandoned, and the industry went back to the drawing board. In 1970, the grocery industry formed the Ad Hoc Committee for a Uniform Grocery Product Code, later renamed the Uniform Product Code Council. The committee's mission was to create a single, standardized product identification system that every grocery manufacturer and every grocery retailer in the country could use. The key word was uniform. Previous attempts had failed because different companies and different stores used different coding systems that were incompatible with each other. The committee wanted one code, one standard, and one system that would work everywhere. The committee solicited proposals from technology companies across the country. 7 different barcode designs were submitted for consideration. The leading contender initially was RCA's bullseye design, which had the advantage of being readable from any angle but the disadvantage of smudging during printing. Then IBM submitted a last-minute alternative designed by an engineer named George Laurer. Laurer had worked with Norman Woodland at IBM, where Woodland had been employed since 1951. Laurer took Woodland's original concept and reimagined it. Instead of concentric circles, Laurer arranged the lines in a simple rectangle of vertical black and white stripes. The rectangular design was far easier to print accurately on product labels. It could be produced on existing printing equipment without the distortion problems that plagued the circular design, and while it could not be read from any angle the way a bullseye could, advances in laser scanning technology meant that scanners could read the rectangular code quickly enough to make the angular limitation irrelevant. On April 3, 1973, the committee selected Laurer's design as the industry standard. The Universal Product Code was born. Every UPC consisted of 12 digits encoded in a pattern of vertical lines. The first 6 digits identified the manufacturer. The next 5 identified the specific product. The final digit was a check digit that verified the code had been scanned correctly. The system could encode over 100 billion unique products, more than enough for every item produced by every manufacturer in the country. Now the industry needed to prove that it actually worked in a real store with real customers and real products. NCR Corporation, the company that manufactured most of the nation's cash registers, built the first commercial barcode scanner. The scanner used a helium neon laser that projected a beam onto a spinning mirror, which directed the light upward through a glass plate built into the checkout counter. When a product was passed over the glass, the laser beam reflected off the barcode pattern, and a photodiode detected the reflected light and converted it into a digital signal that a computerized cash register could decode. The test site chosen was the Marsh Supermarket in Troy, Ohio. NCR selected the store because it represented a typical American grocery operation and because Troy was near NCR's headquarters in Dayton and its research facility in Cambridge. On the night of June 25, 1974, a team of workers moved through the store, applying barcode labels to hundreds of products on the shelves. NCR technicians installed the scanner and connected it to the store's new computerized register system. The following morning, at 8:01, Clyde Dawson, head of research and development for Marsh Supermarkets, pulled a 10-pack of Wrigley's Juicy Fruit chewing gum out of a shopping basket and presented it to cashier Sharon Buchanan. She passed it over the glass plate. The scanner read the barcode. The register displayed the price. The beep that accompanied the scan was the first time in history that a UPC barcode had been used to sell a product. The choice of chewing gum was not random. Dawson selected it deliberately because one of the biggest concerns about the UPC system was whether a barcode could be printed small enough to fit on tiny products. A pack of gum was about the smallest thing you could buy in a grocery store. If the barcode worked on gum, it could work on anything. Wrigley had found a way to print the code on the gum's packaging, and by choosing that product for the first scan, Dawson proved the system's viability on the most challenging possible test case. The adoption that followed was slower than the industry had hoped. The scanners were expensive. A full system cost a store roughly $200,000 to install, a significant investment for an industry with profit margins measured in fractions of a penny. Industry consultants estimated it would take at least 3 years for a store to recoup the investment through reduced labor costs. Many store managers, particularly at smaller chains, were not convinced the savings would justify the expense. Consumer groups added another complication. When stores began removing individual price stickers from products in favor of shelf labels, consumer advocates protested. They argued that without a price tag on every item, customers would have no way to verify that they were being charged correctly. They feared that stores would use the barcode system to raise prices without customers noticing. Consumer organizations lobbied for legislation requiring stores to maintain item-level pricing even after adopting barcodes. Several states considered such laws, and the threat of mandatory item-level pricing made some retailers question whether the barcode system was worth the political headache. No federal item-level pricing legislation was ever passed, but the controversy slowed adoption for several years. By 1978, 4 years after the first scan, only about 1% of grocery stores in the United States had installed barcode scanning systems. The industry had a working technology and a proven standard, but it was struggling to convince individual stores to make the investment. The tipping point came in the early 1980s, when Walmart began implementing barcode scanning across its rapidly growing network of stores. Walmart's founder, Sam Walton, understood something that many smaller retailers did not. The barcode was not just a faster way to check out customers. It was a data collection system that could transform every aspect of retail management. Every scan generated a data point. Multiply that by thousands of transactions per day across hundreds of stores, and the barcode became a tool for understanding consumer behavior, optimizing inventory, and managing supply chains with a precision that manual systems could never achieve. When Walmart demonstrated that barcode data could reduce inventory costs, minimize waste, and increase profitability, the rest of the industry followed rapidly. By the mid-1980s, most major grocery chains and large retailers had adopted barcode scanning. By the early 1990s, the system was essentially universal. The UPC barcode expanded beyond grocery into every retail category, from clothing and electronics to books and pharmaceuticals. It became the foundation of modern supply chain management, enabling the just-in-time inventory systems that allow manufacturers to produce goods only as they are needed, and retailers to stock shelves with a precision that would have seemed impossible in the era of the clipboard and the pricing gun. The story of the barcode is different from the other stories in this series. It is not a story about a right that was denied or a protection that did not exist. It is a story about a problem that was so ordinary, so embedded in daily life, that nobody thought of it as a problem until someone solved it. Every grocery store in America operated the same way for decades, pricing every item by hand, checking out every customer by manual entry, counting every can on every shelf with a clipboard. It was slow, it was expensive, it was inaccurate, and it was accepted as normal because nobody could imagine an alternative. The alternative was conceived on a beach in Miami by a 27-year-old who was thinking about Morse code. The idea sat dormant for 25 years because the technology needed to make it work had not been invented yet. An engineer turned circles into rectangles. A pack of chewing gum proved the concept at 8:01 in the morning in a supermarket in Ohio. And it was adopted not because anyone mandated it, but because once the data started flowing, the economics were too compelling to resist. That pack of Wrigley's Juicy Fruit gum is now in the Smithsonian National Museum of American History. The barcode printed on its wrapper, a small rectangle of black and white lines that looked like nothing special to anyone who saw it that morning, set off a chain of events that reshaped global commerce. Billions of barcodes are scanned every day on every continent, and every single one of them traces back to a set of lines drawn in the sand by a graduate student who was trying to solve a problem that a supermarket manager in Philadelphia had asked about 6 months earlier. The next time you hear the beep of a barcode scanner at the checkout counter, remember that before 1974, that beep did not exist. Every price was a sticker applied by hand, every checkout was a number typed into a register, and every inventory was a count on a clipboard. And the technology that replaced all of it started with a finger drawing lines in the sand on a beach in Miami, because a young man thought Morse code might have one more trick left in it.